All right, today we're jumping into two of the absolute cornerstones of C programming, arrays and functions. Seriously, if you're ready to level up from writing simple little scripts to building actual powerful programs, you've got to know these two concepts inside and out. So let's get right into it.
So let's start with a problem that every single programmer hits pretty early on. You learn about variables, right? They're great for holding one piece of information. But what happens when you need to handle a whole lot of information? Not just one thing, not 10 things, but maybe hundreds of similar things. Suddenly you've got a data overload problem. Just take a second and actually think about that. You're building a simple app for a school. You have 100 students, and you need to store a roll number for every single one of them. With what you know so far, how would you even begin to tackle that? Your first thought might be, well, I guess I'll just make 100 different variables. Roll number 1, roll number 2, roll number 3, all the way to 100. But you can probably feel right away why that's a terrible idea. It's clumsy, it would be an absolute nightmare to manage, and what if the school gets a new student? This whole approach just doesn't work. We need something way, way better. And that better way, my friends, is the array. Think of an array as the perfect organizer for your data. It's like a neat, tidy container where you can put all your related information in one single place. Now let's break down the official definition, because every word here is important. An array follows a few simple rules. First, its size is fixed. You decide how big it is right at the start. Second, and this is a big one, every single item inside it has to be the same data type. All integers, all characters, you get the idea. And third, all of these items are bundled together under one single variable name. And just like that, our 100 variable problem is solved. So how do we make one? It's actually super simple. Look at this line, int mark 5. Let's break it down. Int tells the computer, hey, we're going to store integers in here. Mark is the single name we're giving our container. And that square brackets, that's us telling the computer, please set aside enough space for exactly 5 integers. That's it. Okay, now listen closely, because this next point is a rite of passage for every C programmer, and it trips up almost everyone at first. In C, we don't start counting at 1, we start counting at 0. So in our array that has a size of 5, the first slot is at position 0, the second is at 1, and the very last one is at position 4, not 5. Burning this into your brain will save you so much frustration down the road. And this slide just shows the difference so clearly. On the left, a normal variable holds one value. Simple. But on the right, our array mark is holding 5 different values, all under that one single name. If we want the first value, we just ask for mark at index 0. Need the third one? Ask for mark at index 2. See how clean and efficient that is? Okay, so you get the basic idea of a one-dimensional array, but that's really just the starting point. Once you understand that simple concept, you can start to build much more complex things, like grids of data, or even figure out how C handles text. So get this, you can have an array of arrays. We call these multi-dimensional arrays. A 2-dimensional one is just like a spreadsheet or a chessboard with rows and columns. A 3-dimensional array, well, you can think of it like this Rubik's Cube here, which has height, width, and depth. And here's what that looks like in the code. Int data 3, 3 gives us a 3x3 grid. To get to any one of those boxes, you just need 2 numbers, a row number and a column number. So if you say data 1, 2, you're asking for the item in the second row, third column. Remember, we start counting at 0. So what about text? Words and sentences. Well, in C, a string is really nothing more than a special kind of array. It's just an array of characters. The only little trick is that C needs a way to know where the text ends. So it adds a tiny invisible stop sign at the end, a special character we call the null character. Okay, cool. Arrays have solved our data overload problem. We're feeling pretty good. But as it often goes in programming, you solve one problem and a brand new one pops up. And this time, it's the problem of repetitive code. Just imagine you have your array of 100 students. Now you need to do something to every single one of them, like add up all their marks to find the class average. You'd end up writing the same lines of code over and over and over again, just changing the index from 0 to 1 to 2. For 100 students, that would be an absolute unmanageable disaster. There has to be a way to package up that logic. And that brings us to the second hero of our story, the function. I absolutely love this analogy. A function is basically like hiring a specialist. You give them one very specific job to do, they go off and do it, and you don't have to worry about the messy details. That's really what functions are. They're your own personal, reusable workers. They're little blocks of code that you design to perform one specific task. You write the instructions once, give that worker a name, and then you can call them to do that job for you anytime you want, as many times as you want. So why is this such a game changer? Well, first off, you can say goodbye to copying and pasting the same code everywhere. But it's more than that. Functions let you take a giant, complicated program and chop it up into small, logical, easy-to-understand pieces. And trust me, when something inevitably breaks, it's 1,000 times easier to fix one small worker than to dig through a giant mess of code. So using a function has about 3 main parts. First, you've got the prototype. Think of this like putting an item on a meeting agenda. You're just telling the compiler up front, hey, just so you know, a function with this name exists. Then you have the call. This is the action, the moment you actually say, okay, worker, do your job now. And finally, there's the definition. This is the instruction manual itself, the actual code that tells the function what to do step by step. But how does our little worker know what data to work on? Well, we pass it information using parameters. The real values you give it when you make the call, like A and B here, those are called actual parameters. Then, inside the function's definition, you have these little placeholder variables, x and y, that are ready to catch the data. We call those formal parameters. So the value from A gets copied into x, and the value from B gets copied into y. And what if you need an answer back from your function? You know, a result? Well, that's what the return statement is for. After your function has finished its job, it can use return to hand back a single value to whatever part of the code called it in the first place. And here's the best part. You don't have to write every single function yourself. Not even close. C comes with a massive built-in toolkit of pre-made functions called a library. You need to print something to the screen? Use printf. Need to find out how long a string is? There's stringlen. Need to calculate a number to a power? Use pow. They're all there, ready to go. So let's wrap this all up. If there's one thing you take away today, it's this. Arrays organize your stuff, and functions organize your actions. You use arrays to manage big collections of similar data. You use functions to package up blocks of code you need to use over and over. And learning how to use them together, that is the real key to writing clean, efficient, and truly powerful programs. You now have the fundamental 1-2 punch of programming: arrays to manage data, and functions to manage your logic. This opens up a whole new world of things you can build. So the only question left is, what problem are you going to solve first?